For the first question, a metal bar with an initial temperature at 25 degrees Celsius is immersed in a container of boiling water. It was observed that the temperature of the metal bar increases 3 degrees Celsius in 1 minute. Determine the time required for the metal bar to reach 85 degrees Celsius. So from there, we need to find the important information. So highlight it. Based on the question given, the initial temperature of the metal bar is 25 degrees Celsius, and then the metal bar is immersed in a container containing boiling water. So the important information we get is initial temperature is 25 degrees Celsius, the temperature change is 3 degrees Celsius per minute, the boiling water is 100 degrees Celsius, and we want to know the time taken to reach 85 degrees Celsius. We can solve this question by using the DE of Newton's law of cooling or warming, which is dt over dt equal to k in the bracket of t minus tm, and we need to change the form so we can integrate it, so it becomes dt over t minus tm equal to k dt, and integrate both sides of it, and we get ln t minus tm equal to kt plus c. Solve the ln, and we get t minus tm equal to e to the power of kt plus c, and then summarize it in t equal to tm plus e to the power of c e to the power of kt, and we get t equal to tm plus c e to the power of kt. So that is the equation that we use to solve the problem. As we know, the temperature for the boiling water is 100 degrees Celsius, and the initial temperature is 25 degrees Celsius. By using the equation that we get from before, which is t equal to tm plus c e kt, we need to find c. To find c, we need to insert the known value to the equation. It will become 25 equal to 100 plus c, so c is equal to negative 75. So it will be t equal to 100 minus 75, and don't forget the e to the power of kt. Hence, the equation will become t equal to 100 minus 75 e to the power of kt.
Next, we will find the constant k. Okay, since the temperature of the water increased 3 degrees Celsius in 1 minute, so first we take the equation from the previous work where t equal to 100 minus 75 exponent to the power of kt, and the temperature for this time is 25 plus 3 because the increase of the 3 degrees Celsius equal to 100 minus 75 e to the power of k, and t is equal to 1. So 20x equal to 100 minus 75 e to the power of k, and e to the power of k is equal 24 over 25. Next, we will ln both sides, where ln e to the power of k equal to ln of 24 over 25. We are aware that ln e is equal to 1, and ln e to the power of k is equal to k ln e, and it is the same of k. So we get that k is equal to ln 24 over 5. And the final we get this is k is equal to negative 0.040x2. And for the t, temperature is equal of 100 minus 75 e to the power of negative 0.040x2 t. Now we will find the time taken for the metal bar to reach the temperature of 85 degrees Celsius. First, the equation is t equal to 100 minus 75 exponent to the power of negative 0.040x2t, and the t is 85 equal to 100, which is 100 is the temperature medium surrounding, and minus with 75 exponent to the power of negative 0.040x2t, and we will get that the exponent of the power negative 0.040x2t is equal to 1 over 5. And we will learn for the both sides, and we will get that the time taken for the metal bar to reach the 85 degrees Celsius temperature is 39.43 minutes.
Question number 2. A tank contains 300 liters of fluid in which 20 grams of salt is dissolved. Brine containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute, and the well-mixed solution is pumped out at the same rate. Find the amount AT of grams of salt in the tank at time t. Here we can find several important information. Based on the question given, it stated that 20 grams of salt is dissolved in 300 liters of fluid. 1 gram of salt per liter is pumped into the tank. The rate is 5 liters per minute, and the well-mixed solution is pumped out at the same rate. So now we want to find the amount of grams of salt in the tank at time t. How to solve it? Here is the solution. We know that dA over dt equal to rate in minus rate out. So first of all, we need to find the value of rate in and rate out. The salt was entering the tank at the rate of 1 gram per liter times with 5 liter per minute equal to 5 gram per minute. Meanwhile, the salt leaving the tank at the rate of AT over 300 gram per liter times with 5 liter per minute equal to 1 over 60 gram per minute. Then we substitute the value into this formula and simplify it. It will become dA over dt plus 1 over 60 A equal to 5. Since the integrating factor of linear differential equation is e to the power of t over 60, we can write the equation as d over dt in bracket e to the power of t over 60a equal to 5e to the power of t over 60. Next step is by integration. We integrate both sides of the equation and we get e to the power of t over 60 equal to 300e to the power of t over 60a plus c. Integrating the equation and solving for a, we get the general solution of at equal to 300 plus ce to the power of negative t over 60. For the last step, by using this equation, we need to find c. To find c, we need to substitute the known value, which is when t equal to 0, a equal to 20. It will become 20 equal to 300 plus c. So c equal to 20 minus 300 equal to negative 280. Hence, we get that c equal to negative 280. Thus, the amount of salt in the tank at time t is given by AT equal to 300 minus 280 e to the power of negative t over 60 gram.